Welcome back to Net 125. My name is John Arkey. This is Module 2, Basic Switch and End Device Configuration. So this is going to talk a lot about how we can deal with Cisco iOS devices and how to configure them to best support our infrastructure. So our objective is to implement initial settings including passwords, IP addresses, and default gateway parameters on a network switch, as well as end devices. We haven't quite moved up to routing just yet, simply because we're building it hierarchically the same way we would if we were actually structuring a network. So let's look at iOS access first. There are three separate layers that we talk about when dealing with iOS access. We have the shell, which is user-facing, the kernel, which is between the hardware and the software, and the hardware itself, the underlying electronics of the devices with which we operate. So when we input a command into the shell, it has to be interpreted by the compiler, passed through the kernel, and then interpreted by the hardware as actual physical instructions. We're most often used to working in what we call a GUI, Graphical User Interface. GUIs allow users to interact with their system using an environment of windows, menus, icons, drag and drop stuff that we can see. GUIs are much more user-friendly and don't require as much knowledge of command structure. So things like Windows, we see that all the time. Mac OS, Linux, Apple iOS, and Android for our mobile devices. GUIs can fail, however, crash, or simply not operate as they are specified. How many times have you seen a memory error or blue error pop up? It happens. For these reasons, network devices have to be configured much more precisely and operated through what's called CLI, or command line interface. The purpose of an operating system is to allow you to input data, output data, process data, and store data. So input, output, processing, and storage. Those are the four primary functions of a computer. And then we also have to make the operating system provide a level of interface for that to work. So the operating system enables us to use a mouse to make selections and run programs. We can also enter text and text-based commands, so we can do both. In Windows, you can open up a command window or a PowerShell window and be able to enter things in a command line environment without having to strictly be running a command line-based operating system. Now, a CLI-based operating system, especially a network-based operating system like iOS, enables network technicians to use a keyboard to input commands, and we can view that output on a monitor. So if you look at something down below, you'll see the analyst @secops username. That is a Unix shell, which is very similar to what we would see in a terminal-style CLI environment. The console is a physical management port, what we call in-band services, that we use to access a device to provide maintenance. So initial configurations, primary setup of all of our remote access stuff, it's all done through console. SSH, or secure shell, establishes a secure CLI connection over a remote network interface. So secure shell and telnet are actually what we need to be able to remotely configure a device using what we call out-of-band services. So once we've established the in-band services through the console, we can then establish out-of-band services through either of these two options. This is connected in secure shell format through a virtual interface over a network. This is usually going to be abbreviated as SVI. This is the recommended method for connecting to a device remotely because secure shell includes encryption. It doesn't send things in plain text as Telnet would. Terminal emulation programs are used to connect to a network device in an environment that doesn't natively support it. So if you were to be on Mac OS or things like that, there is actually what's called a bash terminal that's included as part of the OS, and that will allow you to connect in a much more effective way. But if you're on Windows, or if you want to use something that's streamlined regardless of whether or not it's a cross-platform thing, we can use things like PuTTY, Teraterm, or Secure CRT. These different interfaces allow us to set up the same features that would be necessary for a direct network operating system CLI-based connection. As you can see in the graphics on the right, they can specify the host that you wish to connect to, what form of connection type you wish to use, whether or not you want to save certain login settings. Maybe you have a username or password that's too complex to keep retyping. So on your admin machine, you keep that logged in. Or in TerraTerm down at the bottom, we can see that it's a much more simplified interface. Now, once we're in, how do we get around? Well, we have to deal with what are called modes. The one that we see when we first log in is called user exec mode. It's an abbreviation for executable. So user exec mode allows access to a limited number of monitoring commands. We can see just kind of what's going on. We can see here that the greater than symbol, the little arrow pointer there, also called the output symbol, is what terminates the CLI prompt. So you can see that it says router greater than or switch greater than. Some people, call it the alligator or whatever else. I just remember it as a greater than or less than symbol. In privileged exec mode, you'll notice that the prompt changes. It's now a # or hash or octothorpe, depending on your reference. This allows access to all commands and features, and there are sub-modes inside of privileged that allow us to access other things. So subconfiguration mode for global configuration lets us set up configuration for the device. So you would type in enable to go into privileged exec, type in config T to go into terminal, and then you can make changes such as switching around the host name or certain things like that. Line configuration mode lets us go in and change things like the console, our settings for remote access over SPI, such as the SSH or Telnet encryptions, or auxiliary access. Auxiliary is not used very often, but as security technicians, we have to be aware that if aux is enabled, we have to secure it like we do any other access port. Aux acts the same way as console, except it does it over a RJ11 cable instead of RJ45. So this can be done over a phone line as opposed to a network or Ethernet cable. We see here that it says config line when we're in this mode. If we go into config IF, this is configuration for an interface. This is where we're going to set up a port or a router interface. So let's say that we have 24 fast Ethernet ports on a machine. Those will be identified by int, which is the abbreviation we would use for interface. You can type out interface fully if you wish. FA, which is the shorthand for fast. And then you would type in 0/1 or 0/ all the way up to 24. 0 basically says this is the interface that we're working with, and then the port in question is numbered. So if we have an 8-port switch, we would have fast Ethernet 0/1 up to 0/8. If we have gigabit interfaces, then it would be 0/1 or 0/2. If we have a serial interface, which we'll talk about in a later chapter, we would have 0/0/1 because we talk about what slot the interface is in as well as the interface itself. Privileged exec mode, in order to switch, as I talked about just a second ago, we type in the word enable. In order to leave configuration mode in this way, the most common thing is to use the exit command. So if we're in global config, or if we're in privileged exec mode, or if we're in line config mode, we can type in exit and it will jump us back to standard privileged. If we want to go back to global configuration from, all the way to privileged exec from a sub mode, we can type in end. So exit jumps back 1 level, end will jump back 2 levels if we're that deep. To move from one submode to another, if you type in the interface directly, it's actually pretty intelligent about getting through that. When you get into net 126 and eventually 225, you see quite a bit of discussion for that, being able to move through these things quickly, especially when we get into scripting. So speaking of scripting, we have to understand how the command structure works to be able to pass things from one place to another. So we have 4 main components that we talk about when we talk about the sentence structure or command structure or syntax of iOS. And we have a prompt, which tells us what level or mode we are in, a command, in this case we're using show, a space to separate the command from its arguments, and then the arguments are keywords that allow that particular command to be manipulated. So in this case, show IP protocols or ping 192.168.10.5. These are showing complete commands. The prompt tells us what mode. The command at the top would be show. We have a space to separate, and then IP, and that's actually a primary keyword, and then we have a secondary keyword in protocols. And we'll talk about the drill down nature of assessing these commands very shortly. A keyword, for those who aren't familiar, is a specific parameter defined in the operating system. An argument is not predefined. So this is a variable or something that's user defined. If we're trying to ping something, if we give it an address, that address is not a predefined keyword. So that's something that we have to give as an argument. That's why when we say keyword or argument, we can also use the interchangeable term parameter. As commands will sometimes require more than one argument, it's important to understand the syntax of how we structure things. So bold-faced text, that shows commands and keywords if we see something in bold. Italic would indicate an argument. Square brackets indicate optional elements. Braces indicate required elements. Braces and vertical lines indicate a required choice within an optional element. So if we have here we have X in squares, it's optional. X in braces or curly braces, sometimes you'll hear it referred to, that's required. At the bottom line we have square bracket X, curly brace Y, pipe Z, close square, close curly, close square. So the Y or Z, which is indicated by the pipe, shows us a required option. Okay, so it sounds weird to say required option. It's a required element within an optional. So we're going to have X, but we could have Y or Z, but we have to have both if we're going to use the option. So getting used to that structure takes a little time. Thankfully, we have the help command, which is contextually based. We'll talk about that again, yet another item a little bit later on. Here we can see a continuation of this. Here we can see ping and then the IP address, which is not how it would be written. Just indicates an argument that would be passed in by the user. For the command trace route, we see the same item. It just depends on, you know, the command in question. They all have different structures, so the question mark key is going to be very helpful for us. If we see a command with multiple arguments, we may see it represented like this. So switch, that tells us the host name of what we're on. Now that's not to say for sure that it is a switch. You could actually name a router switch if you wanted to mess with somebody. I don't know why you would, but you could. It's in configuration interface mode. It's in privileged exec mode, obviously, because we're in interface mode, but you see that the hash is there as well. The command is switch port. There is a sub command called port security, a third called aging. And now here we start hitting the options and requirements. The requirements here is that we have to pick a specific type of switch port security diagnostic. Do we want to use static, time-based, type-based? If we choose static, then that's it. If we choose time, we have to specify what time. If we choose the type, then we have a second requirement of is it an absolute or inactivity-based type. Now, port security is not something you're going to talk about just yet. That's going to be Net 126, but it is something that we play with quite a bit, especially when we get into inter-VLAN routing, trunking, things like that. iOS has two forms of help available, and this is what I've mentioned, kind of hinting at, if you will. Context sensitive and command syntax check. Context sensitive help lets us find answers to questions like what commands do I have access to based on the mode? What commands start with a particular character or group of characters? Or I know what keyword or command I want to use, but I don't know what the parameters are to activate it. So for example, if you wanted to be able to set up the clock and you typed in the word clock and you hit question mark, it would tell you what the next parameter is. And you would do it sequentially. You go into clock, set, and then you start doing your arguments to pass that through. Command syntax allows us to verify that a valid command was entered. There are three primary errors that we will experience in iOS. Either an ambiguous command, meaning that you could have, you know, a three-letter shortcut that starts off two different commands and you haven't added in something that will specify one or the other. Computers don't like ambiguity. You can have an incomplete command, meaning that you've given it the key word or you've given the command, or both. But there's another piece that's still missing. So the stuff that you've included is perfectly legal. It just hasn't finished it yet. It's kind of like when you stop talking mid-sentence. And then lastly, something being incorrect. You can see here that it says interface fast Ethernet 01. And we're seeing a problem there. And it says invalid input detected, and that's because we're in privileged exec mode. We're not in configure terminal mode. So we're not global config yet. You have to get the global config in order to get to the submode interface. Okay, so we can see there that it's a legal command in a different mode. CLI also lets us have hotkeys that make things a little bit easier. So we can hit the tab key in order to complete a command. We can just type stuff in as long as we have a unique selection. So if we were to type in con, as you can see in the upper graphic, it identifies it as being ambiguous between configure and connect. If we move to the second item, you see that if we type in conf, then only one item starts with conf. Same thing as if we were to type in conn. And there's only one entry in that particular mode that would provide a valid entry and allow us to proceed with the parameters. So tab completes a partial name command entry. This can make sure that you're spelling something correctly. Beware, because on the actual CCNA assessments, I believe they turn this off. It's been a hot minute since I took the certification myself, but I believe they do turn the partial commands off with the tab key. Keeps people from just kind of spamming through what the different options are. Backspace, you don't have delete, you only have backspace, so you can move the character one to the left and erase it, but you cannot delete one to the right. The left arrow or right arrow will move your cursor, as well as Control B or Control F. I've never tried using those. They seem kind of uncomfortable to me, but they are things that I guess you could use if you needed to. The up key or Control P will start to cycle through the recent commands in the history buffer. So for those of you who have used DOS or DOSBox or Bash or any kind of Linux-based environment, you'll notice that the last commands that you used in CLI will be preserved. So you'll be able to go back through what you've typed. This allows you to prevent having to retype a command multiple times. So I've seen that people who have gone through and are like, okay, I need to configure X number of interfaces rather than using scripting because there's just enough difference that they have to modify. They can at least use that to say, I want to make sure they're in the same subnet. So I'll do 192.168.2.11, 2.12, and it'll already have the subnet mask and everything else in hand. Again, once you start getting into stuff like that, I would really recommend using scripting instead, typing out your text file and then just pasting it in. When a terminal window is basically containing more text that can be displayed in a single frame, it'll display a more prompt at the bottom. In order to work with this, if you hit enter, it will give you the next line. If you hit space, it will give you the next screen. So if you want to think about it this way, it's a line return versus kind of like a page down situation. If we hit anything other than enter or space, it will end the display string and jump back into privileged exec. If we are in any configuration mode and want to go back to privileged exec, we can use Control C, which is what's called a break command, jumps us back. You can also do that with Control Z. Now Control Z is intended to work in configure terminal mode, but it does work in any configuration mode. Control Shift 6, this is an all-purpose break sequence specifically to abort actual things that are in sequence. So a very common error is somebody tries to type in a command, mistypes it, and because of the mode that they're in, the switch will try and interpret this as a host name. So it'll say, trying to look this up, whatever it is, and it'll wait to time out because it's looking for a computer that's named whatever you mistyped, command instead of command maybe, something similar, and it'll just sit there and it'll spin, it'll spin, it'll spin, and you can't really do anything with a mouse, so you have to use the keyboard for that. So Control Shift 6 will allow you to stop that from happening. Convenient thing you can do is if you go into terminal configuration for global mode, you can type in what's called no IP domain-lookup, and that will turn off the automatic domain search so that it won't throw that problem up for you. When you get into the Packet Tracer Labs, that is definitely something I recommend that you do. Basic device configuration. The first configuration on any device should be to set up a unique host name. By default, everything's given a default name based on what it is. So switches are called switch, routers are called router, things like that. Your conventions are start with a letter, end with a letter or digit, so no special characters. Letters, digits, and dashes are the only acceptable entries. No spaces, and keep it under 64 characters in length. I don't think there's actually an error that it'll throw for that, but it gets really messy. It starts creeping across the screen and taking up more than one line just to enter in a username. Try and keep them as concise as you can while still remaining descriptive. If you need to return a device to its default prompt, so if you want to go back to switch, I wouldn't type in, host name switch. I would instead just type in no host name. And that's true for a lot of interface stuff. If you have a password for something and you want to disable it, you would just type in no password after you're in the correct mode. To activate an interface, you instead of typing shutdown, which would turn it off, you type in no shutdown, and that activates it. Something that Cisco has done for a good long while is instead of including two commands that reverse each other, they just have the same command with a no in the front in order to negate. We want to make sure that when we're working in privileged mode or anything else, we always have passwords. In order to make sure that those modes are not easily broken whenever we're working in them, we want to make sure that there is a password. Passwords, of course, are highly fallible compared to other authentications, but we do still have to use them. So we want to make sure we avoid passwords that are considered to be weak or easily guessed. So no dictionary words, no personally identifiable information. Make sure you're not using repeating sequences. So no 1234 or 2468, no 999 or 555. Avoid using capital letters for the first character of a password, and avoid putting numbers at the end because that's what most people do. You want to try and scramble it up a little bit. I like services like LastPass in order to help generate secure passwords, but be aware they will sometimes include characters that are not considered valid. Now, most examples in this course are simple passwords such as Cisco or class. This is because we want to eliminate some of the stress of, oh, what was that password again, and having to reset your work. So we have kind of these dummy passwords. But make sure that if you're working in production that you do not use passwords of this caliber. They are not considered to be safe by any means. A lot of the time we'll enforce what's called a min length on passwords to where it'll have to be at least 10 characters, and these are obviously only half of that. To secure user exec mode, we'll give you an example here, and again, we're using the password that we don't recommend. Go into line console 0 from terminal mode. So you're going to go into enable, you're going to go into config T, and then you'll go into line con 0 or line console 0 if you want to type it out in long form. Next, we're going to specify the user exec password by using the password command. So that would be password Cisco in this case. And then we're going to make sure that the login command is turned on so that way it will automatically default to requesting a login rather than assuming it should let you in. In privileged exec mode, we should also go in, and this can be done before we go into the line for console, and type in enable secret and then whatever your terminal password is that you want to use for privileged exec. So the privileged exec is the first one you'll type in because that's the one that you're trying to access it, in terms of mode, getting into the private stuff. But if you're accessing something remotely, then the first one you'll deal with is user exec mode. If you're hooked in via console, it won't ask you for a password right away unless you put this in and turn on login. You could actually turn on a password, not type in login, and it wouldn't recognize it. So another thing we have to be aware of is what's called the virtual teletype lines, VTYs. VTYs are used for remote access for Telnet or SSH, and we can have up to 16 at one time for the most part. So the lines go from 0 to 15. Now we have to specify which lines we're working with. We have to do the range. So some people will do 0 through 4 and 5 through 15 separately, or 0 through 15 together. That is entirely up to you. Just follow the conventions that are given to you whenever you establish yourself with a different IT firm. You're going to go ahead and put in your password, type in login to authenticate that the login system will be looking for a password, and then you type in end. And that will go ahead and save what you need. Startup config and running config display most passwords in plain text. So in order to make sure that that's not the case, we need to use a service, and that service is called password-encryption. I believe if you type in serv space PASS and hit tab, it should auto-complete that for you once you're in global config mode. Now you will want to make sure that you run the show running config command after you've done this to make sure that the passwords on your device are now encrypted. Banner messages, this is something that's important because you want to make sure that anybody who tries to access your device has at least a perfunctory warning that says, if you're not supposed to be here, scram, there are consequences, etc. You want to avoid any text that says anything inviting or the word welcome or anything like that. So in order to do this, again, we have to be in global config mode. You'll type in banner MOTD, message of the day, and then whatever the text is separated by what we call delimiters. So the delimiters they use here are hashes. I've seen people use percentage signs. I've seen people use ats. There's any number of things you can do. I like the hash just because it's already a character that's reserved as part of the prompt. So it keeps you from accidentally using something that might be considered a character that is reserved somehow for. I'm trying to think of an example. Like exclamation points traditionally mean not in programming. Not the case on iOS, but there may be a situation where you can confuse yourself by mixing up scripts. So how do we save stuff once we've made these changes? Okay. Well, we have to think about the structure of how this is recalling information when it first boots up. We have what's called the startup config. This is the list of options that is the default to retrieve when everything starts up. It does not lose its contents when the device powers off, so it's much more like the firmware or the hard drive of a standard computer versus the RAM, which is when we reboot, goes away. Cleverly enough, running config is stored in RAM. That's active memory. It's dynamic memory. So that's the stuff we've been changing. All the stuff we've been typing in to make these modifications, that's in RAM. Modifying running config affects operation immediately. RAM is volatile memory, so it loses content when it loses power. It has to be constantly refreshed. In order to save the running configuration to startup, we use the copy command. And the copy command has two parameters. It has to say, what are we copying and where are we copying it to? So if we type in copy running-config, startup-config, it gives us exactly that information. We say that we're going to copy the current configuration that's running in RAM and move it to the startup configuration to allow the system to keep that saving change whenever it reboots. Now, what if we have a situation where we don't want to save our settings to running config? Okay, well, we can just reload the router or switch, and it will automatically go back to whatever the previous configuration was. We can also go in and remove our changes manually, but I will say that tends to be a little bit messier. If we have some changes that were saved that are problematic, it may be necessary to clear out startup config and restore it to the defaults. To do that, we're going to need to use the erase command. So erase startup config will be what we use here, and we'll hit OK. If we have a VLAN set up, we'll need to erase VLAN.dat. It's a .dat data file, it's just text-based, and make sure that that is gone as well, otherwise you may have some conflicting results. Configuration files can be saved and archived to a text document, or they can be copy and pasted. If you're using something like PuTTY or TerraTerm, you can actually turn on session logging. I believe a newer version of PuTTY actually has a hotkey that you can use. I think it's specifically something that's not related to anything iOS does. It might be like the Windows key or something similar. Terminal logging can be turned on for printable output, SSH packets, everything in the session. I would say everything in the session, just because you don't want to only have the printable stuff. Then you're going to give it a name, and you can also insert some what are called special characters, so you can have a date, time, host name, etc. And you can have a pop-up if you have any changes that you're making, such as the file already exists. Do I add stuff to the end of it? Do I overwrite it, or do I ask the user? You want to make sure the flush log file thing is checked, because otherwise the buffer will fill up. And make sure you omit known password fields if you are logging SSH. You don't want to accidentally reveal those. Essentially what that does though is it just outputs it to a text file that you can go back in and modify, which I've done on numerous occasions. Definitely saves you a lot of time. Now, once the logging has begun, you can go ahead and run show running config or show startup config, and it will output all of those items to the chosen file. Once that's done, you can flip it back over to none, and it will turn off the logging option. Ports and addresses. So the use of an IP address is the primary means of establishing location. IP addresses are supposed to be unique on the network to which they are connected. So if we have a local IP address like 192.168.1.15, then that would mean that on our particular network, that can be the only device that has that IP. Now that's not to say that another person in a different area, a different subnetwork, could not have the same address, but if they were to talk to each other over the internet, or just over a LAN that has these different subnets, they would need something called network address translation to move it out to a different network first. So that information would have to be passed through an intermediary that could translate one to the other. The structure of an IPv4 address is called dotted decimal and is represented by 4 decimal numbers between 0 and 255. These are the minimum and maximum values that can be represented by an 8-bit binary number. So if we have 4 of them, 4 times 8 gives us 32. So the 32-bit value that we generate here is called the 32-bit IP address. That's our binary address. There's also what's called a subnet mask, which is a 32-bit value which is combined with the IP address to give us what's called the network portion, separating it from the host portion. We don't really do a whole lot with logical operators in this class right away, but what you'll know is that whenever you're doing an AND, you're going to see very quickly whether or not something is considered a yes or a no. If we AND a yes and a yes, logically we say that two things that are true have to be true. So 1 plus 1, rather than thinking of them as numbers, think of them as true or false representations. True and true be true, true and false would be false, because if it's an AND, both of them have to match. And then false and true, which is the same thing, just inverted, and then false and false. So true and true is the only thing that gives us a 1. That means that if we have a string of 1s, which is what a subnet mask is, it's going to give us only the areas that have a 1 involved. And the first time that we hit a 0, which is the end of the subnet masks cannot have a portion where they become 0 and then resume 1s, that will trim off any host information. And we'll get into that in much greater detail later in the semester. IPv6 is even more complex. They decided to go ahead and take it to 4 times the length because, hey, we're running out of IP addresses. About 4.3 billion addresses when IPv4 was established. Now with IPv6, I believe it's 38 undecillion, which is a massive number. I think it's actually more than the grains of sand on a beach. It is representable as 32 hexadecimal values. Every hex digit is represented by 4 bits, which is how we get a 32 value address that is 128 bits long. So we're just condensing. Now, groups of hexadecimal digits that are called hextets, 4 of each, are separated by colons. IPv6 addresses are not case sensitive, so you can write, the A through F letters that are involved in upper or lower case. Now, network communications depend on end user device interfaces, the actual devices that we're handling, the transition devices or intermediaries that move to and fro, and the cables that connect them. There's 3 primary methods of transmission we talk about: wireless, fiber optic, and twisted pair copper cables. Coax is very similar to copper cable, it just doesn't have the twist, so that's why we tend to blend those two together. Now, different types of network media, of course, have different features. They also have different benefits, the amount of distance they can cover, the amount of speed they traditionally handle, security options, etc. The things we need to consider are how fast can the media successfully carry a signal, in what environment will it be installed, the things like the bend radius would come in at that point, the amount of data and speed that must be transmitted, and the cost of the media and installation. Now, of course, with fiber optics, these tend to be the fastest and have the best range. There's one that's currently in operation that goes between Bilbao, Spain and Virginia Beach, Virginia. It weighs somewhere on the neighborhood of 4.4 million pounds. It's the thickness of a garden hose and runs at 10 terabits per second. It's owned by Microsoft and Facebook, if that gives you any idea of how much money was probably put into it to get it installed. So let's talk about how we configure IP addressing. We need to have an IP address to be able to communicate between these end devices. Now, as I said, it doesn't necessarily have to be globally unique. That's more of a restriction we put in for IPv6. And even then, it's more of a convention. IPv4 address information can be entered manually, or it can be automatically acquired using what's called DHCP, Dynamic Host Configuration Protocol. Now, you can see from the graphic on the right that we have a manual entry. We've established an IP address, we've established a subnet mask, and we've established what's called a default gateway. A default gateway is a local device's path, if you will, to an external network. So let's say that to connect to the internet at large, you have to go through one device, a router. You don't have a switch involved. This is just a for instance. That means that your local IP address, in this case 192.168.1.10, has to be converted to something that's publicly unique, 68.202.1.4. That's the IP address that your ISP gives you. Or if it's a layer that goes between a switch, then a multi-layer router, and then another router and another router. You can have these onion layers, if you will, separating you from the internet at large. That default gateway is just the next device in line. So it's not going to be your ultimate connection, it's just whichever one it has to do the next step. DHCP draws from what they call a pool of addresses. So when we set up DHCP, again, something you'll see a lot more in Net 126, you establish a range of addresses that are considered valid. And those addresses are then assigned one at a time to any device that requests information that has the correct credentials to log in. If we use IPv6, we have what's called DHCP version 6 and what's called SLAC, Stateless Address Auto Configuration, for dynamic address assignment. Now, we talked a little while ago about the VTY lines to be able to get in and work on a switch or router remotely. How do we do that? Well, we have to set up a web interface. Not necessarily a web interface, but definitely an internet interface. So we would use something like an SVI, Switch Virtual Interface, that requires an IP address as well as a subnet mask. So in this case, we type in config-t to go into global config mode, type in interface VLAN1, and that VLAN, or virtual local area network, now needs a local IP address as well as a subnet mask, and it needs to be administratively activated. We'll type in the IP address, we'll type in a subnet mask, and we'll type in no shutdown, or no shut, and that will go ahead and turn it on. That's how the SVI is artificially powered, if you will, because it's not a physical interface, it's just a software-based interface that goes through the VTY lines. Here are our new terms and conditions that we've established for this chapter. We can see we have things like shell, kernel, CLI, GUI. Familiarize yourself with these terms because you will see them again, and they are things that will help you to accurately communicate between yourselves and other professionals in the networking field. Thank you so much for your time and attention, and I'll see you next class.